You ready? All right, guys. So gonna really like take a step back. If you haven't been doing very well on the first couple days of your stoichiometry practice, this is a good jumping in point for you because I changed up the practice for today and made it much simpler than any of the practice we've done. And I'm gonna kind of just restart. So for folks that have got it, just bear with me. For folks that feel like they're lost in this section, this is a good place to jump in. Okay, so let's start with a pretty simple equation, and then just ask a couple questions about it. So we'll say, tough to make up equations off the top of your head, but let's do a combustion equation. So if you see these little nozzles on the desk beside the sink, those contain propane gas. We'll hook those gas up and light some Bunsen burners up probably later in the year. And so we'll show the chemical reaction with that propane gas. So you have the propane gas, C3H8. And how does it burn? What is it combining in the room with to burn? Very good. Combining with oxygen, getting a little bit of activation energy. And then anytime you burn anything, you found out in The Martian, you're making water and carbon dioxide, H2O and CO2. All right. Another cool thing about today's assignment, yes, sir. Another cool thing about today's assignment is that I switched it. I switched up the reactions today, so they're already balanced for you. So if you didn't do well in the balancing test and you don't really get balancing, no problem, because I've already balanced them for you. But just a real quick reviewing of the balancing: 3 carbons, 1 carbon, 8 hydrogens, 2 hydrogens, 2 oxygens. 4 plus 6 is 10 oxygens. 5 times 2 is 10 oxygens. Okay, I'm doing that quick just because it's something we've already done, and because of the practice today, you don't need to balance. Okay, so a question you might see today is, if you have 17 moles of oxygen, how many moles of propane will react with it? Okay, so all you have to do is use what's called the mole ratio. So we're going to write down 17 moles of oxygen. We're going to draw our fraction. So this is one of those tests where if you can do that right there, if you can do that, write down exactly what you have and then draw your fraction. That'll get you unstuck a lot. A lot of times I see people that are doing this stuff and they're like, I'm stuck and I don't know what to do. Write down exactly what you have and draw your fraction. Get used to doing that really fast. Write down what you have, draw your fraction. Because once you have that fraction, you remember the next question. I have moles of oxygen. I do want them or don't want them? You don't want them. Where do they go? On the bottom. Moles of oxygen. Always put your units of what you want to talk about and then get your numbers. Moles of oxygen on the bottom, and then moles of propane, which is what I want, on the top. Now, when you're going from moles of one thing to moles of something different, it's all about the coefficients in the balanced chemical equation. What kind of numbers are coefficients? The big numbers, exactly. They're the big numbers. So we have what coefficient here? 3 and 1. If there's a blank, the coefficient is 1. Okay, so for mole ratio, it's all about those coefficients. So I don't want moles of oxygen, they go on the bottom. What's my coefficient? 5. And what's my coefficient here? 1. Now let's go back to the math we talked about the other day. We multiply across the top and divide what's on the bottom. What's on the top? 1. Multiplying times 1 does what? It stays the same. It's a waste of my life. You all right? Okay. So the only math I'm going to need to type in the calculator is
divided by 5.
17 divided by 5. And that's it. And you have the answer, you do a dance. 17 divided by 5. Hook me up there, Matthew. I see you holding it. All right. 1 point off. Why? Because I didn't say what 3.4 was. 3.4 is always what the last thing here is. Moles. If you put moles, I probably count it full credit because it's what it's asking for. Moles C3H8. 3.4 moles of C3H8. I always like going back and looking and asking the question, does it make sense? We're going from 17 moles of this oxygen to moles of this. That number is higher or lower? 3.4 is going to be higher or lower than 17?
Lower.
Lower. Does it make sense that 17 dropped to 3.4 when I went from 5 to 1?
Yeah.
Yeah. So we roll on. If you came up with an answer that was 34, you might say, that don't look right. Because going from 5 to 1, how do you go from 17 to 34? Does that make sense? I'm a big fan of common sense when it comes to math. My daughter's in 7th grade right now, and she's doing math, and she's doing percentages and things, and she'll do a math problem where it says, this gnome is on sale for $20, 30% off. Okay, and she'll come up with the answer. Well, how much does it cost? And she'll come up with the answer, $25. And I'm like, okay, let's think about that. Does it make sense for it to cost more if it's 30% off? You see what I'm saying? Look at what your question is and say, does it make sense? Does it make sense? I got smaller when I went from 5 to 1. Absolutely. And that way you can always kind of see, did I do something wrong? Okay, let's use this same formula and ask a little bit more complicated question. And I'll even stick with 17 moles. This time, instead of 17 moles, instead of going to moles of methane, I want to see how many liters of water I made. Okay? So we're going to start out exactly the same way. 17 moles, O2. I don't want moles of oxygen. Now, we're going to do the exact same thing this time. Instead of switching from moles of oxygen to moles of propane, I'm going to switch a mole of oxygen to moles of water. Okay, I can't go to liters because you can't go from one thing to another if you're changing what you're talking about. You can only go moles to moles. You can only change from moles to moles when you're talking about two different things. So I can go from moles of oxygen to moles of water. And just like my last question, I get my numbers from my coefficients. How many moles of water are up there?
4.
4. And how many moles of oxygen?
1.
Look again.
Wait. 4.
Look again. 5. No problem. Okay. Now, if I stop there, my answer would be in moles. Is the question asking for moles? So I need one more step. And this step is really easy because this step is always the same. I don't want moles of water. They go on the bottom. I want liters of water. Now, here's another mistake somebody's going to make. Because somebody's going to say moles of water, it's 4. The only time you use a number other than 1 to be moles is when you're doing this. Moles to moles. And you use your coefficients. Any other moles you're talking about, any other time in chemistry, how many moles have we got? 1. It doesn't matter if you're going from moles to anything else. Moles to liters, moles to grams, moles to particles, moles to atoms, moles to molecules. Doesn't matter. 1 mole. And your number is always the same for liters in a mole. $22.4. Does it turn so I can see it? Yeah, 22.4. 22.4 liters in 1 mole if you're talking about volume. Mathing it up, we're going to multiply, then we're going to divide. We're going to say 17 times 4 times 22.4, smash my enter button, and then Divide by 5. Knock it out real quick for me, guys. Let's see if everybody agrees.
We're at 304.6.
Got a vote for 304.6? I got a second. Do I got a third? I'm waiting.
Yep.
All right, they only gave me 2 numbers. I'm only going to give back 2 numbers. I'm going to just let's say 304. Or 305, round up for the 0.6. If you put 304.6, I'm not counting it wrong. If you put 305, I'm not counting it wrong. I'll be honest with you. If you put 304, I'm not counting it wrong. Be completely honest, if you put 300, I ain't counting it wrong. As long as you got the setup. Does that make sense? Okay, now, still 1 point off though. Say it loud.
The unit.
What is it?
You own the unit.
What is it?
Moles?
Nope.
Liters?
Liters. All right. I think one more, and then I want to see some pretty practice from you guys because I feel like you guys are knocking it out. All right, let's do the first example on your practice for today. If I can get it to bring up. All right, first example of practice for today has copper plus silver nitrate plus copper nitrate, whoops, yields plus 2 Ag. Before we do anything else, just a quick review. What type of reaction? Synthesis, decomposition, single replacement, double replacement. Synthesis, decomposition, single replacement, or double replacement? Close, not quite though. Only one replacement because you got these guys by yourself. These guys are by themselves. So copper comes in, pops out that Ag, single replacement. Okay, that was on the last test too. I just wanted to check you out. So let's read the question. According to the biochemical equation, Ka-chow, how many moles of silver stop there? Where is silver by itself? It's only in one place.
2 Ag and a 3.
Down at the very end. Nope. That's not silver.
Oh, wait, no.
That is silver nitrate.
Yeah.
Okay. This is something that confuses people too, because they say the question says 2 mole, how many moles of silver? And they're like, well, there's 2 silvers. No, there's only 1 silver. This is silver. This is silver nitrate. Make sense? Yeah. When it says just silver, it's just talking about silver. How many moles of silver will be produced from combining 15 moles of copper with excess silver nitrate? What does it mean when you have excess?
Extra.
Sort of. So if I say you have excess of something and you're figuring out how much you need to make, or you're figuring out, you're doing math about something, and I say you have excess of it, what does that mean to you? Exactly. More than you need, extra, you're not going to run out. So does it matter how much you have? No. So when this question says excess silver nitrate, I read in my chemistry brain, it doesn't matter. Silver nitrate doesn't matter because you're not going to run out. So the only thing I care about is the copper. How much copper did it say I need? I have 15 moles. Okay, so I'm going to write that down. 15 moles of copper. And I'm going to draw my graph. So if you can get that far, you can answer just about every question. Because now everything else just guides what you need to do. I don't want moles of copper. They go on the bottom. I want moles of silver. Where do I get my numbers here? The coefficients. What's my coefficient for copper? Very good. And what's my coefficient for silver? You might not even need a calculator for this one, because all you're going to do is what? 15 times 2. But you add a little bit extra there. You might want to use a calculator. Say it loud. 30. Look at that. I mean, this is one of the things that you hear horror stories about. Like, man, that chemistry class, man, they started doing stoichiometry. I got no idea what that man's talking about. But when you break it down to a single step, it's not that bad. You just do what you need to do and roll on. Questions, problems, thoughts? All right, you got 4 more on the practice for today. Let's go ahead and knock that out. I'm here for you. I'm going to go ahead and make tomorrow's practice and get that ready as well.
Is that a 2 or Z?
There's no Z's up there. Maybe a crooked Z. It also would make sense to have Z moles or something. All right, so I'm gonna let the folks on the internet go, post this video up, and I'm gonna look at the market.